Welcome back, everybody. I'm Tamar Granor, and this is Create Complex Graphs with GraphViz. A little bit about me. I've been working with FoxPro and Visual FoxPro for more than 30 years now. Done a ton of writing about it, including quite a few books, and written for Fox Rocks and FoxPro Advisor. And of course, I'm one of the organizers of this event. In 2007, I was honored to receive the Visual FoxPro Community Lifetime Achievement Award, and I also was a Microsoft Support MVP from the beginning of the program in 1993 until they stopped awarding it for FoxPro in 2011. Today, we're going to talk about an open source product called GraphViz, and I've divided this material into 4 parts, a little bit of an introduction of what is GraphViz and what do you use it for. Then we'll talk about how you work with GraphViz generally. Then I'll talk about how to make it easy to work with GraphViz in VFP. And then we'll talk about how to make the results look better. The plan for Q&A for this session is that you should put your questions in the chat for the stage, and I'll pause a few times and ask for questions. Then following this session, I'll have a separate Q&A session. You'll find it after this session. In the Sessions tab, it should say Q&A with Tamar Granor. Okay, so what is GraphViz? I've been working now for about 4 years helping move a vertical market application that was written in FoxPro for Windows into Visual FoxPro. The application is for managing, it's for produce distributors. And a couple of years ago now, the client came to me and said, we'd really like to be able to show our customers, our users, some graphs of the data that we're doing. In particular, some graphs, why don't I just go there, that show the life cycle of a particular lot of materials. And he'd already done a little research and said, here are a couple of products I think can do what we want. And I think GraphViz is the one we're going to want to use. So I went, downloaded and installed it and started playing. And in about 40 minutes, I was able to write a piece of code that could create a specific graph, nothing generic, but I was able to create what he wanted from a particular sample data set. Then I went ahead and said, okay, now how do we integrate this into this application? And ended up producing pretty much what I'm going to show you today. So this example shows a case of cantaloupes being ordered. This neon green triangle is a purchase order for actually not one case, but a batch of cases of cantaloupes, and what happened to them as they moved from the purchase order to being sold. And we really don't need to go over all of this. I'm just going to say that some of them got cut up into chunks with parts, what are called culls here, that got thrown away, and then the chunks got used in fruit salad, and then the fruit salad got sold. Other parts actually got repackaged into different size cases, and those got sold as well. The important thing is that I was able to create this without having to do the graphics myself. I was able to set up something that said, show this in this way, produce this chart. So what is GraphViz? It's an open source project for making what the creators call graph visualizations. And when they use the word graph, they're talking about it in the mathematical sense, a graph being a set of nodes and some edges that connect them. And so what this project was designed to do is take those mathematical graphs and visualize them, show them what we would call graphically, show them in a way that was readable. GraphViz includes several different engines that turn descriptions of graphs into images of graphs. We're going to work today with an engine called DOT. We'll see that a little bit later. The site for the project is graphviz.org, and I have that open here. So this is the site. And it has this gallery that lets you see some examples of what kinds of graphs you can create. And I'm going to scroll very quickly just to show that there's a huge variation in the kinds of things you can create. And then I opened a couple of them up so we could just take a deeper look. This was created, I know nothing about Linux, but this is a diagram of the Linux kernel. That's the result. And down here, we can see the description file that was used to create that. We'll go into what that looks like in a few minutes. And here's another example. This one is showing some data structures. Something looks a little more familiar, the kinds of things we work with a little bit. And again, down on the page then is the graph description that was used to create that. So how do you use GraphViz? Well, of course, you go to this website that I just showed you and you download it and install it. When I installed it again to write the paper for this session, I found that one file was missing. I'm sure it was there when I did it originally several years ago, but it was missing. I've included that file in the downloads for this session. Okay, so that's what it is. Let's talk about how you work with it. I've already said a fair amount about what's involved, but let's be more specific. You have to create what I'm going to call a graph description file. This is a text file, and it describes the overall graph and then the nodes and the edges of the graph. And the graph itself, the nodes and the edges, each have attributes that are provided in an attribute value kind of notation. Once you've created that graph, then you pass that file to an engine. And as I said, there are several different engines, and their engines are essentially command line utilities. Although I'm going to show how we do that without having to do it from the command line. So that's the basic process. Let's look at an example. This is the result we want to get. This is an org chart for the Northwind database. It's a pretty basic one. We're going to see something a little fancier later in the session. But still, it looks pretty good. So if that's the result we want, what does the graph description file look like? This is the graph description file for that chart. It has really four kinds of components, actually. First, there's a header. This digraph means it's a directed graph, that it has arrows in it, and it has a name, and then everything else happens inside curly braces. So I'm calling the part up to the curly brace, the opening curly brace, the header, and the closing curly brace, the footer. Inside the braces, we have attributes for the graph, we have definitions and attributes for nodes, and we have definitions and attributes for edges. The first two lines here are graph attributes. Rankdir equals TB means draw this from top to bottom. Rankdir can also be LR, draw it from left to right. The second line describes the label that described the graph. Let me just go back and show you that. Here, Northwind employees. So this label, it has the text Northwind employees. It's located at the top, justified to the left, 24 points. All of the lines here that begin with a number and then have a square bracket are node definitions. Every node has an ID, and for this example, I used the primary key of the employee to be the ID because I already knew they were unique. Then inside the square brackets, we're specifying, well, what's the label on that node and what font should we use? So that's all the lines that look like that. And then the ones that have this arrow in the middle are the edges. I'm saying draw an edge from node 2 to node 1. And because it's a directed graph, that matters because we're going to get the arrowhead. Let me go back. So node 2 is Andrew Fuller. Node 1 is Nancy DeVolio. So I said from 2 to 1, we get the arrowhead over here. And so on. So once you know how to read it, it's a pretty simple file. And you're probably already having some pretty good ideas of how you would create such a file with VFP code. The third step, oh, and I should say in that example, the edges don't have any attributes. We'll look at edge attributes later in the session. So then the final step in creating the graph is to run the engine. Here we're going to run this engine .exe, and we've got a path to it. And this, what you're seeing on this slide, all belongs on a single line, but of course that wouldn't fit on a slide. The T flag here says what file type are we creating. You can create all manner of graphical files. You can also create PDFs and PostScript files and HTML. There's a whole bunch of different things you can create, and it varies among the engines. The second line here is the source file, the graph description file. It doesn't need a flag because it's the one required parameter. You simply have to provide it. The third line here is the output parameter, small o, and then the path where we want to put the resulting file. Because this comes out of the Linux world, case matters, so small o and uppercase O are not the same thing. Small o is the one we use for this. So that's the basics of what, if you were going to use this without involving Visual Fox Pro, what you would need. Are there any questions at this point?
None at this time, Tamar.
Great, then we'll just go on. So let's talk about how we would use GraphViz from VFP. What I did for my client and what I've done then for this paper, they're in the downloads, is a set of wrapper classes that make it easy to create the graphs. They basically give you a scaffolding so that for any given diagram graph you want to create, you just have to do the graph specific parts. The hierarchy has 3 levels. The top level is a very generic class for GraphViz called GVGraph. The second level is a dot specific class that incorporates information about working with dot. And then the third level is going to be the one that you create for a specific graph. And we're going to look at a bunch of examples now. We're almost to the point where I show code. So let's talk about the generic class GVGraph. It's an abstract class that is instantiating. It isn't going to do you any good. And while it has a whole lot of code in it, there are 2 principal methods that you're going to use. MakeGraph is going to do the whole job of creating the graph. It's going to create the graph description file and run it through the engine. And then showGraph is there for just displaying the graph once you've created it. So, off to code. We'll start with GVGraph. And we've got some properties to hold on to, things we're going to want to know. I'll talk about them as they come up. But the MakeGraph method, as I say, is the first of the principal methods. And it's got 2 parameters. They're both optional. The first parameter is the name of a cursor that contains the data we want to graph. The second parameter is what output format we want. So we do some introductory stuff that I'm not going to talk about now, and then call the specified graph data method. And there's an interesting thing going on here. When I originally wrote this code, I expected that the cursor would already exist and we'd just pass it in. But then I realized there might be situations where you actually want to build the cursor of data inside the class. So specify graph data is an interesting method because what it does depends on that parameter you pass. It allows you to either accept a cursor coming in or create your own. So if you pass an actual cursor name, a character, it'll just call a method that sets a property to that name. But if you don't have the name of a cursor, then it will call the getGraphData method. That's an abstract method here where you're going to put in the code to actually build the data. We'll see examples of each in this session. Let's go back to MakeGraph. So once we've gotten our hands on data, then if the format was passed in, we call a method to save that to a property. And then I went too far. And then we do the actual work. For error handling in this class, I have a property, as you can see error messages, and there's an add error method that gets called here and there when something goes wrong. So if there's nothing in see error messages, we know everything so far is fine. And if that's the case, we'll call the generate GV file. That's going to generate the graph description file. And then if everything went well there, we'll call generate graph. So let's go take a look at these two. Generate GV file is a template method, as was really make graph. It doesn't do the work itself. It calls a bunch of other methods. So we do some error checking here to make sure that we actually have a data cursor. And assuming we've got a data cursor and it's open, then we go make a name for the graph description file. It's just generating a random name. And then the interesting stuff happens down here near the bottom. We make sure we're looking at our data cursor. We call generate GV header, which will generate the header part of the graph description. And then we loop through the data cursor. And for each record, we generate a node in the graph. And then we generate any edges. And what it doesn't say here, but it's any edges in which that node is a child, because you cannot generate the edge until both of the nodes involved have been created. So you have to write generate GV node edges to work in the cases where you're looking at the child, not the parent. We'll see examples of that as we go. And then finally, after the loop, generate graph footer. So right now, none of those four methods have any code in them. This is just abstract to set things up. Once this has been done, as we saw, we call generate graph. And generate graph, again, does some error checking. It makes sure it has a path to the GraphViz engine that we're going to use. We'll see that getting set in a subclass. We make sure that we have the graph description file, both that we have a name for it and that the file already exists, because there's no point calling the engine if we don't have the graph description file. And then we deal with what format. We're going to default to JPEG if we don't say otherwise. And we're going to make sure we have a name for the output file. That's what this case statement is doing. It's taking the graph description file and generating an output file name that's the same except with the appropriate extension. And down here's where the actual work happens. We generate a name, create bat file, simply gets a name for a batch file. It doesn't actually put anything. The main first part of the work here is generate graph call. This is abstract at this level, but it's going to create that command line that allows us to run the appropriate engine. And then I just use string to file to put those in the specified batch file. Then we'll run the batch file. And that's the whole thing. We'll just handle errors. Run batch file is one of the reasons I wanted a wrapper class, because this is sort of ugly stuff. Save the error handler, replace it with did an error occur, call run with the batch file, and return whether an error occurred. So that's the whole graph generation process. A little bit abstract because we haven't seen the low-level stuff. What about show graph? Once we have the graph, we're going to, well, we don't have to, but often we'll want to display it right away. So show graph, make sure that the graph actually exists. Well, make sure we have a name for the graph file, and then make sure it actually exists. And I put a delay in here, a 3-second delay, because in the client's application, they're getting displayed right away. And even though the batch file is finished, the actual file may not have been written. So we check for 3 seconds. If it still doesn't exist, we get out of here. Otherwise, we call a method called showGraphNative. In my client's application, they actually store locally information about what application somebody wants to use to open a particular kind of file. It's kind of an override to the Windows defaults. And so when I wrote this, I set it up so we could either use the Windows default or what the application is storing. I ripped out the extra part for this because, of course, you don't have that mechanism. So we call show graph native, which is it calls a function named execute file. This is a function that Doug actually wrote. It's just a wrapper around shell execute, but it's nice to not have to declare shell execute, and it returns the success code so we can indicate if there was a problem displaying it. So that's everything that's happening in this top level. No, it's not everything, actually. There are a few things we didn't talk about. A couple of them we'll come back and talk about a little bit later. But that's the key things that are happening in this top level class. The second level class is a dot specific class. We now are going to write a class that knows that we're targeting the dot engine. And so we can put the pointer into where is the dot engine located, and we can fill in some of the template, some of the code that was abstract at the previous level. Let's take a look at that. So this is the subclass of GVGraph called GV.graph. And in the setup method, which we didn't look at before, and it had no code in the base class, we call set GVPath and pass it the path to dot.exe. I have it installed in the default location. So if you install it somewhere else, obviously you'll have to deal with that. And then we were able to fill in a couple of other things here. The generate graph call method we can do in full now, because we know which engine we're using and where it's located. And we know what parameters we need. We need to pass the T parameter for what format we want. And then we need to pass the name of our graph description file, and then the O flag for the output. And we return that string so we can get written to our batch file. The other thing we can do here is we can generate the header and footer, because we know what a header and a footer for a dot file look like. We saw an example of this a little while ago, digraph. I just arbitrarily am naming these GV file. If you had some other name you wanted, or if you wanted to generate unique names each time, you could do that. And the open braces. So we're going to write that. And then the two sets of graph level attributes we can do at this stage also, the rankdir and the label attributes. So we can do all of that at this level. And then the graph footer, which is just the closing curly brace, we can write at this level. Rate graph line is a simple piece of code that uses string to file to save the string you pass. So this class is pretty simple, this subclass. Where things will get interesting is at the next level. We're going to now create that graph that I showed you earlier, the org chart for Northwind employees. We have three things we need to do. We need to set up the data, take the Northwind data and put the employee data in a format that will allow us to create the org chart. Then the only piece that we still need to do within the graph is generating the nodes and the edges. Those methods haven't been filled in and we need them. And then we need to actually run the graph, which we're going to do with a separate program. So let's go look at each of those pieces. Start with something that has nothing to do with graphing. This program is going to build the employee hierarchy. I'm not going to go into how this works because I've spoken about this before, and there are articles on my website that show how to run this kind of code, dealing with hierarchical data and pulling it out in the format we want it. But what we're going to pull out is the first and last name of the employee, what level they're at in the hierarchy, the first and last name of their manager, this employee's ID, and the manager's ID. And when I run this program, this is what we get. And the important thing is to notice that they are in hierarchical order, that we have the guy at the top of the hierarchy first, then the people who report to that person, and then anybody who reports to any of those second level people. And because they're in this order, we'll be able to generate the graph the way we want to. So here's our next subclass of GVGraph. This is actually a subclass of GV.graph because we want all that dot stuff in it. In the setup method, we're going to go ahead and say explicitly we want JPEG. We're going to set this to be top to bottom. And we're going to set a title for the graph of Northwind employees. The interesting stuff begins in the next method here, generate GV node. So in this method, we know we're coming in and we're going to be looking at the current record in the cursor, in that manager hierarchy cursor that we just looked at. So make sure we're in that cursor. And as I said earlier, the ID that we're going to give the node is going to be the primary key for the employee. So we're going to call the getNodeID method, which is one of the things that was in the base class in GVGraph that we didn't look at because it was abstract. We're going to pass in the ID, and all it's going to do is convert it from integer to string because we need strings for the node definition. GetNodeLabel is going to look at the current record, and it's going to take the name and create a here, we'll look at it. It's going to create the name and create one string from it with trimmed everything and looks nice. So we're going to get those two values, and then we're going to generate a string for that node with the node ID, and then inside square brackets label and the label that we generated. And then we'll specify the font using the font that we've specified in the class. And that's really all there is to it. We write that out. And then the generate GV node edges. We're going to pass in the node ID of the node that we are currently talking about, the one we just are working on. And what we want to do is draw the one edge from the parent of this node to the node. So we're going to look at the current record. And if its manager ID is not empty, if the manager ID is empty, then this is the person at the top, and we don't need to draw a line. If it's not empty, we call getNodeID and turn that manager ID into a string. And then the line for the edge is pretty simple. The parent ID, the arrow, and the node ID. So that's all it takes in this class because of everything that's in the parent classes.
Tamar?
Yeah?
We have a backlog of questions, if you wouldn't mind.
I was going to just show the code that runs this and then take questions.
Okay, sounds good.
Yeah. Okay. So I have a little program that's going to run this. We're going to call that NWAMPS program to get the data. We're going to instantiate our class. And then assuming that all worked, we just call the makeGraph method, passing in the manager hierarchy and the type we want. And if everything went okay, if there are no errors, call the showGraph method. If there were errors, show the errors. And then at the end here, I'm just going to open up the graph description file to show it. I didn't think I changed it, but. And here we go, the same one that we saw on the slide. It's always exciting when the first example that you run works. And here is the same graph description file that we saw on the slide. Okay, and now I'm ready for questions.
Okay, Ahmad is asking, can you put hyperlinks in the graph?
I don't know the answer. I wouldn't be surprised because you can generate HTML. I think the answer is probably yes.
Okay. Earlier you talked about delaying checking of a file existing for a few seconds. Wouldn't a sleep call work better in that scenario?
You could, but the way I'm doing it, as soon as the file's ready, you'll be able to to show it rather than always waiting 3 seconds.
Okay. Bernard asks, is there a DLL as well, which could be used instead of the executable to generate the graph?
I don't think so. And given, as I said, that this comes, it comes out of the academic world, which is more of a Linux world. So I'd be surprised if there's a DLL because they're cross-platform.
Yep. Tom asks, why are the nodes in the nice hierarchy? I just saw nodes and connections.
I'm not sure I understand the question. Why are the nodes? Oh, you know what? Let me see if I can reopen that, run this line and reopen this and talk about how it gets the hierarchy. No, it's out of. I think the answer is that's the magic that's going on inside of GraphViz, that it can do the evaluation and figure out what goes at the same level and what goes at a different level. I think that's really the big value that it brings to the table.
Right. Barbara asks, I assume that if you output to a JPEG, you can use that in a VFP report?
I believe so. I haven't actually tried it, but I believe you can.
Mm-hmm. Can this be, Bali asks, can this be exported with a right click and a copy? I'm thinking maybe from your Photos app, maybe.
Exported to, like to send it to somebody?
No specific detail is provided.
Right. So you end up with a file, and you can do with that file whatever you want to do. You know, I chose to show it, but you could,
okay.
You could do other things with it. Okay.
All right. I'll let you get going. There's a lot more questions coming in, but we'll get those in a minute.
Cool. I'm delighted that people are finding good questions to ask because those were all good. Okay, but let's move on, because that was a pretty basic graph, and you can do a bunch of other things with this. There are a lot of ways that you can go from the basic looking graph that we saw to something that's more attractive or interesting. You can modify nodes, you can modify edges, you can modify the graph itself. So let's start with some really obvious visual things. You can add different shapes and colors. In the example I showed at the beginning of the session for my client, there were shape and color were both showing the same attribute. In this example, I'm using shape to show the level in the employee hierarchy and color to show the job title. We're going to look at those one by one. I just want to, well, let's start with shapes. We're going to use shapes to show the level in the hierarchy. The top is a box, the second is an ellipse, the third is a diamond. And if you look at a couple of lines here from the graph description file, you can see that for the node whose ID is 2, which is Andrew Fuller, the shape equals box. For number 1, which is Nancy DeVolio, the shape equals ellipse. So how do we do that? And I mentioned that there were some things I didn't show you in the GV graph class originally. So let's go back and look at a couple of things there now. There's a method here that gets called at the beginning called create color shape cursor. And for my client, it created a single cursor. Here it creates 2 cursors. It creates one for shapes and one for colors. Each of them has a 2-character ID and then the name of the shape or color. GraphViz lets you specify shapes and colors a number of ways. I chose to go with the simplest, which is using character string values. For color, you can use things like RGB and so forth as well. So these are just lookup tables that I set up so that you could look up what shape or what color to use for a particular node based on some kind of a code. And the 2-letter codes worked really well in my client application. I would think people applying this in their own applications might want to change that to something, maybe an integer code or something. And then we have methods. We're going to look at getNode shape. The get does what you would expect it to do. It's a lookup into that cursor. So you pass in, what did I do? You pass in that 2-character code, and it does a lookup in the cursor. And returns the result. And notice that I've provided something random here, not random, but something we're not using, just in case we don't find anything, so it returns a shape rather than returning nothing. Because if I have nothing when I generate the code, it's going to be a mess. And the getNodeColor method is analogous. So now if we go look at a different subclass, this one is not a subclass of the one we just looked at. This is an alternative subclass of GV.graph. It has much of the same code in it. And then what's changed is the generate GV node method. Well, actually, there's one other that I want to show you first. There's a method called load colors and shapes that gets called early on. And in this case, we're just populating the shapes cursor. I'm using level numbers 1, 2, and 3, box, ellipse, diamond. And then generate GV node has a little more code than it did the last time. It's pretty similar to what we saw before, but I've added this one call in here to get node shape. I'm transforming the level from integer to character because the method expects character, and it returns the shape. And then the line that generates the node, I've added this portion where shape equals and wrapped in quotes the name of the shape. And then the rest of this is the same as it was before. So now I have a slightly different version of the run program because it's going to instantiate this new class in this new program. Otherwise, it's the same. When I run that, it takes a moment. So now we still don't have color, but now we have the different shapes for the different levels in the hierarchy. And I know that informationally, that's not terribly interesting. I just needed something I could show you. Okay, but let's move on and talk about color. Now, here, we'll just take a quick look here at here's the new graph description file. It's the same as the last one with the addition of the shape information. Let's pop back to the slide for a moment, because what I want to show is when we talk about color, there are actually a couple of different things going on. By default, color just means the border color for a node. But I can specify whether the node is filled or not. And if the node is filled, then there are two ways I can specify the interior color. I could specify the fill color attribute, and that would be separate from the border color specified by color. But if I say that a node is filled and I only specify color, then both the border and the interior will use that color. And that's what we're doing here. A little later, we'll see an example with separate border and fill color. So if I look at this next version of, before we can look at the next version of the class, in order to color based on people's job title, we actually need the job title. We hadn't pulled that out earlier. So this is a modified version of the code that gets the employee information, and it adds the title. Let me run this just so you can see that the result is it's the same as before, except we have one more column that includes the job title. All right, so what is the class doing? The new version of the class, and again, this is a different subclass of GV.graph, starts the same. It has the load colors and shapes method has a little more code in it because now it's got to load up the colors based on abbreviations. And so where this got interesting was that this expects a 2-character abbreviation, but the job titles are full strings. So what I did was I wrote a method, convert title to abbreviation, that takes the full job title and based on some part of it, I decided that if this were a large organization, I'd really want all the manager, all the vice presidents, all the managers, all the representatives, all the coordinators, each to have the same color, whether they're sales or production or whatever. Maybe not, maybe you'd do it differently. So I am converting based on that part of the job title, returning the 2-character abbreviation. And this version of generate, actually, we want to look at one more method. We want to look at get node color. Here I extended the method. The original method took the 2-character abbreviation, did the lookup, and returned the color. Here I'm passing in the full job title, calling convert title to abbreviation, and then using do default to pass the abbreviation and get back the color. So then on generate GV node, it's not very different from the last version. Thought I hit page down. That didn't work well. It's the same up till here. Then we call the get node color method and get the color back. And then we've added some more code here. In addition to the shape, we now specify the color for the returned color and style equals filled. Obviously, you could make the interior style, you could handle that differently for different kinds of nodes too, if you wanted to. So the run program for this one is pretty much the same as the last one, except we're calling the new version of the one that gives us the job title, and then we're calling version 3 and program 3 here. Otherwise, this is the same. And when I run it, we'll get the result that was on that slide. Here it is. And that's all pretty cool, I think. But this is a pretty basic graph. Can we do more complicated things? Obviously, or I wouldn't be asking. So I thought about what example could I do that would really be helpful for database developers? And I realized that it would be really nice to be able to diagram a database, to show all the tables and the persistent relations among those tables from a database. So this is what we have for the Northwind database. The arrows are showing the parent and child in a persistent relation in the database. Employees, as we know, because we were just using it, has this relation to itself. And I think this is really pretty cool. It turned out the hardest part of this was figuring out how to organize the tables in a cursor so that they were in the order that would let me do this. So let's go take a look. So this time I chose to put the code to build the cursor into the class. And that's because I actually did it the other way originally, but it turned out that there was a situation where I needed to be able to use one of the cursors that was created along the way. There we go, get graph data. I needed one of those cursors in order to generate edges. So I decided it really ought to be in the class because otherwise I couldn't control whether the cursor existed. So how do we do this? I start by opening the database. As we'll see, we're going to pass the name of the database into this class. So I open that database, and the ADB objects function lets me pull out all the persistent relations in the database, and I put them into a cursor. And then I run a couple of queries to figure out for each table in the cursor how many parents it has, which I don't turn out to need in this process, but how many times, I'm sorry, not how many parents it has, how many relations it's the parent in, and how many relations it's the child in. And we're going to need to know how many times it's a child. And then we run a query that pulls, now I'm using the database as a table, and I'm running a query that pulls the name of each table out and joins it to how many times it's a parent and how many times it's a child. And that's the cursor we're going to work from. Well, actually, it isn't. I'm sorry. It's an intermediate cursor. What we're going to do here then, the hard part of this, is putting that list of tables in the right order. So this query that we're looking at now goes into that cursor of tables, and it pulls out every table that's never a child, the ones that are only parents, plus any table that the only time it's a child, it's also the parent, like the employee table. Let's go back and look at that again. So these tables on the left, categories, suppliers, customer demographics, and so forth, they're never a child, they're only a parent. Employees is a child, but the only time it's a child, it's also the parent. So those are the tables we initially pull out, all the leftmost tables here. And then we use a loop to figure out, do we have all of the tables? If the cursor we're now creating is the same size as the list of tables, we're done. Otherwise, go into that list of tables and find all the tables that are there that we haven't already put in the result cursor, and where every table that is a parent to that table is already in the result. That is, go find all the children where we already have all their parents. And we do this until we either can't find any more or they're the same size. I don't actually remember whether you can have a circular set of relations in VFP. I don't think you can, but this will work if there happen to be a circular set of relations where A is a parent to B, which is a parent to C, which is a parent to A. So it won't blow up in that case. So this is going to create the cursor, and we're going to then set the CData cursor property to the name of this thing that we created, cursor table order. As I said, that was the most challenging part. Generating the nodes here is really easy. We're going to use the name of the table as both the node ID and the label. For node ID, it'll be all caps. For label, we're going to make it proper case. And then we just generate the node with the node ID, the label, and in this first version, a filled box in this color, Orchid 1. The edges are where this gets interesting. The edges, we need to go figure out, for the node we're working on, who are its parents. So we go back to that cursor of relations and we pull out the names of all the parents for the current node. And then we loop through those, because in this example, a child can have more than one edge coming to it. In the previous example, while a node could have more than one edge going from it, each employee had only one edge coming to it. Here we may have multiple edges coming to the same node. So we go through the list of parents for this table. We take out of this cursor the parent name and turn that into a parent ID, and then we generate parent, the arrow, and the child's node ID, and write that out. And then we have a run program for this that's pretty similar to the run programs we've seen, with one slight difference, which is it receives the database as a parameter, a couple of differences actually. So in addition to instantiating, in addition to what we did before, there's a new method, set database, that receives the name of the database, stores it in a property. So if that happens successfully, we call make graph, and this time, rather than passing a cursor name, we pass false to say we're going to make the graph inside the class. Still going to use JPEG. The rest of this is the same. But to run this now, I have to pass that parameter. So I have a program to run the program. And we're going to run that. We don't really need to see it. It's just going to pass the Northwind table. And this is the same graph that you saw on the slide. But to show you that this really is generic code, I have another database. Some of you have seen it in sessions I've done in the past. It's called Chinook. It's about an online music store with tracks and albums and artists and so forth. So here's that same class being used to create the table diagram, the structure diagram for the Chinook database. Okay, you know what? I think I probably should take some questions here before I go on.
Okay. Can you change the foreground text color too? And can you add icons or images?
You definitely can change all of the characteristics of the font, including the color. We'll see that a little bit later in the session. I think you can include images. I don't know that for sure. I haven't tried that.
Okay. Can you specify the width and position of the various hierarchy groups?
I don't know.
Okay.
There are some pretty complex things you can do that I haven't played with. And I think it also varies depending which engine you're using and which way you're specifying certain attributes.
Bowen asks, colors now have names. Can you also use RGB code for that? And are there ways to look up the color names?
Yes to both. There are several different ways to specify the colors, including RGB. And the documentation, I didn't show it earlier, but there's some very nice documentation for this project, including all these color names and what they look like.
Okay, so that's it.
Okay, great. Well, let me go on then. I mentioned earlier that we can have attributes for edges. Let's make our edges more informative. We'll start, this is the second example I'm going to show on this slide, what's on the slide, but we'll start by adding labels. It'd be really nice in this database diagram to show what are the tags involved in these persistent relations, right? And we'll do that with edge labels. So I have a new subclass of gv.graph, and we're going to look at just the get node edges method, generate GV node edges. If we want to show what the tags are, we obviously need to know what they are. So we modify the cursor, the query that gets the names of the parents to include the names of the child and parent tags. I played a lot when I was building this example with what separator we should use. I tried several different things, and it turned out the 2 colons with spaces on either side, I thought gave the best appearance. Certainly something you might want to play with. So as before, we will get the parent ID, and then for the label, all we're going to do is trim the parent tag, put the separator, trim the child tag. And then for the first time here, we see a set of attributes for an edge. So it's label equals and the text of the label. Really no different than anywhere else. Although, as you probably noticed in the slide, I didn't remember to specify the font here. We'll do that a little later. And that's the only change we're going to look at here. And so when I run this one, I'll run it just for Chinook because you already saw what that's going to look like for Northwind. So here we can see the tags that are involved in these relations. It happens that in both Northwind and Chinook, there are only a couple of examples where the tags don't have the same name. Okay, what else can we do? As it showed on the slide, maybe a little more subtle, I thought it would be really nice if we could tell which ones are one-to-many relations, and it turns out in both Northwind and Chinook, they all are. And one of the things that you can do in a graph is that the edges can have both arrow heads, as we've been seeing, but they can have what they call arrow tails. And you can specify any of a variety of shapes for that. So here I've chosen something that's sort of a vertical bar for the one side of a relation, and this triangular thing for the many side. So when we go and look at this version of the code, all the interesting code or anything, the only change here is in the generate GV node edges method. So with the same query, then for each edge that we're generating, we have to figure out, is it one or is it many? So we use some nice FoxPro functions. We use the tag no function to go figure out which tag we're talking about for the given table. We're going to open the table for the child, go figure out which tag it is based on the name, and then if it's either primary or candidate, then we know that it's the one side of a relation because those are unique. And then we do the same thing for the parent. Go look up the tag, and is it primary or candidate? If so, it's a one. Otherwise, it's a many. So then when we come down here, we're going to specify if the parent is a one, if it's single, then for the arrow tail, use the shape called T. If it's many, use the one called inv empty. I have no idea where these got those names. I think they're really unintuitive, unlike the shape names and the color names. And we do the same thing for the child. And so now we're going to add several attributes to the edge description. dir equals both indicates that we would like to use both an arrow head and an arrow tail. There are other settings for dir that say only a head or only a tail. And then specify the name of the arrowhead that we want, specify the name of the arrow tail that we want. That's all there is here. So we'll run this one against Northwind. And so now you can see we have these alternative, let's see if I make that bigger. These alternative heads and tails. So that's pretty cool. What else can we do? There are things we can do to the graph itself. We can enhance labels. Somebody asked about font colors. We can specify font colors. As I mentioned briefly, labels we can specify the font name, the justification, the location, the size. Pretty sure we can specify other attributes like bold and italic. I haven't actually played with that, and the color. So let's go take a look. The principal change in this version is in the generate GV header, where we've added to the line for the title, to the title, if we have a title, use a label for it. We're putting it top. Now we're justifying it to the center, using Arial, using blue, using 24 points. And this version also in GV node edges, I've added the font, the Arial font. This actually ought to use the font name in the class, but I didn't catch that when I wrote it. And we'll run this one against Chinook. So now we have Chinook tables and relations, and this is getting better and better looking, isn't it? I know you can't really answer me. So the other thing we can do is or among the other things, there are many things we can do, but among the things we can do is we can change the background color of the graph using the BG color attribute of the graph itself. We can also rotate the graph. Imagine that you have some graph that's going to be, when you print it, it's going to be multiple pages. You might want to set it so that it's printing portrait rather than landscape on the pages, and so they'll come out one after the other. So when you go to tape them together, it's easier. Or so you could print it on dot matrix kind of paper, continuous paper. So let's go look at those examples, and it's actually right here we're again in generate GV header. So we've just added this one line with two attributes: BG color of ivory, rotate 90. And when I run that one, you have to sort of turn sideways to see it, but I hope it comes through the ivory background, and obviously it's been rotated. Okay, questions at this point?
Yep. There is a question about antivirus and anti-malware components. Are they likely to intercept and prevent the creation of running a bat file? Someone also suggested maybe creating a bat file and running it with shell execute.
Right, that's a good question. I don't have a good answer. That would be a question to take up with your IT folks, but people can maybe if people have thoughts about that, then in the Q&A following, they can come and share their experience with that.
Okay, and then Paul asks, will your code work in a database where the tags have different names like employee ID underscore PK and employee ID underscore FK? Yes,
because the ADB objects function that I'm using to pull that information out will pull out whatever their names happen to be. It just happens that the two databases I'm demonstrating with have the practice of using the same name on both sides.
Okay, that's it for now.
Okay, great. So we're there. What we learned today is that GraphViz is an open source product that provides graphing in a fairly simple manner. You create a text file that describes the graph and run it through an engine to produce the output. We looked at how you work with GraphViz generally, and then we looked at a set of classes that makes working with GraphViz with VFP much simpler. Obviously, all the classes and the examples that I've done will be included in the materials for the session. I should say that there are a lot more capabilities in GraphViz, mostly that I haven't really looked at, but among probably the most important is it has the ability to create subgraphs within a graph. And one of the things you can do with those subgraphs is create legends for your graphs. But then there are lots of other attributes as well. Are there any final questions?
Nope, none posted.
Okay, well, so following this session, I will go over to the sessions area to a room called Q&A with Tamar Granor. So if you have other questions that you wanted to get answered, you thought maybe were too specific or that you didn't think of till I stopped talking, please come see me there. I'll stick around a little bit. Please fill out your evaluations. I learned from them a lot. Also, we'll now be taking a long break, so till 3 o'clock Eastern Daylight. You can use this time to go get some food, to hydrate, to take a walk, or you can go visit the sessions, networking, or expo areas to have interaction with other attendees or with our vendors. Thank you very much.